All right, a couple problems from Chapter 6, Section 5. So the overhead reach distances of adult females are normally distributed, so that's important, with a mean of 195 and a standard deviation of 8. Find the probability that an individual's distance is greater than 204.3. So again, we've talked about z-scores. You can convert things to z-scores and then look it up in the tables, but I'm going to use StatCrunch. It gives a nice visual, and so we could just go to our normal calculator, and it wants to know the mean and standard deviation. Well, the mean's 195, standard deviation of 8. 195, standard deviation of 8. And they were looking for find the probability that an individual distance is greater than 204.3. So an individual, so that's one person, is greater than 204.3. So we get this value of 0.1225. So again, that's easy enough. Now, in the next one, we don't have one person, we have 15 people. So when we're doing our calculations, the standard deviation is not 8 centimeters. We need to do the standard error of the mean. And so to calculate the standard error in the mean, and the book says the formula is your population standard deviation divided by the square root of your sample size. So in this case, it's 15. So this is what we're going to put in for our standard deviation this next time, because we're dealing with 15 people. So 2.06559. 2.06, and that'll be close enough. And the idea is that the more people that you sample, it should be closer to the mean. It's the central limit theorem. It's kind of an example is, do you know someone who has given birth a month early? And I think we probably, depending on who our friends are, I know people that have given birth a month early. But if we sampled 30 women and found out the average delivery was a month early, we would think something's weird with the water. For one person, it's not strange. For 30 people, that would be really strange. Again, either there's something biological or environment that's going on, or the biological, like maybe our gestation period is changing to 8 months versus 9 months. So it's going to change the shape of the distribution. It's still going to be normal, but it should be thinner, the central limit theorem, the closer we should get to the mean. So their question is asking is greater than 193.7. And we get that probability, 0.7354. And again, why can we use the normal distribution? Maybe because the original population is normally distributed. That's always a good go at it. Another one from this section is number 7 I want to look at. Number 7, so women have pulse rates that are normally distributed with a mean of 74.7 and a standard deviation of 11.4. So a few parts. Find the percentiles P1 and P99. Again, that's just going to our calculator that we have, 74.7 and 11.4. So we have 74.7, and I think it was 11.4. And we're asked to find the percentiles, P1, so to 1 decimal place, beats per minute. So, looking at a picture, that means I have 1% to the left would be my 99th percentile. And so that gives me a beats of 48.2, right? So we found the number of heartbeats. So 48.2. And then I could do it for the P99. I could say that greater than 1% would be a way of doing it. And so it says 101. Again, nice visual. This is that top 1%, so that means 99% is to the left. So 101.2 would be a good answer. And so now we see 25 patients, right? So again, that changes our probability. Instead of 11.4, it's 11.4 divided by the square root of our sample size. So that's what we're going to use for our standard error of the mean, standard deviation. So we would just have a 2.28, and we would be answering the questions off of this now. And this is just a between problem. I think we've done this before. Between 57 and 93, easily done on StatCrunch because we put 57 and 93. That looks like pretty much everybody, right? With a standard deviation of 2.28, and that's our mean, those are good distances away. So that should be roughly 100% of our population. And if we're rounding to 4 decimal places, I think we would just end up saying 1. And so then a question, try to conceptualize what's going on. Again, since the number of patients went up, it would make sense that the mean of those 25 patients should be closer to 74.7.